Welcome back everyone. In today's tutorial, we are building a fully interactive 3D solar system using React 3 Fiber. We will rotate planets, animate their orbits, and create realistic lighting and textures, including Saturn's iconic rings. As you can see, we can zoom, we can rotate, and we can pan. Well, panning means that we can move the camera around. You will also learn how to add interactive features. When you click any planet, an information panel will open, and we can also pause or resume all animations with a single button, okay? Let's say that now it is stopped and we want to get info about this planet, okay? So now let's resume it. The entire project is broken into clear and understandable parts, and I explain every step, so you can follow along even if you are new to Three.js or 3D graphics. So let's get started. Okay guys, first let's create a new React project using Vite, which is a super fast build tool for modern web apps. So I'll open my terminal and type this command: npm create Vite at latest, and let's say solar-system. So this command will run Vite's project creator and sets up a new project folder called solar system. So let's press enter. So when it asks for a framework, let's choose React, and for the variant I will choose JavaScript. Here I will say no and no again. Next I will move into the project folder, let's say cd solar-system, and let's write npm install. So this will install React, React DOM, and everything Vite needs to run the project. So let's press enter. Okay, so let's open this folder, and as you can see, we have our structure, we have node modules, index.html, and so on. So Vite handles it for us. Now let's start the development server. To make sure that everything works, I will type npm run dev, and we should see a local server address. Okay, so let's open it in our browser. Yes, everything is working since we see Vite's default React page. Okay, so before we start coding, let's clean up the default template. So we have a blank setup. So inside source folder, we can delete assets folder. We can also delete app.css. And inside app.gsx, I will remove all this boilerplate code. So as you can see, now I have hello 3D world, and I will take this text, and inside index.html, I will say, actually, I don't want to use this text, and let's say that inside index.html, I will say React solar system. Okay, so let's save this file. And as you can see, it just displays hello 3D world, so we can confirm that everything is working. Okay, and actually, let's delete our styles inside index.css, so that it means that we will start from scratch. As you can see, now we don't have any styles, and we see only this text. Okay, so now let's open our terminal again. Let's stop it by pressing Ctrl and C. And now we need to install Three.js and React 3 Fiber. So we will install Three.js, which is the main 3D engine, and React 3 Fiber, which allows us to use Three.js directly inside React components. So let's type npm install 3 at react-3/fiber and at react-3/dray. So let's press enter, and while it's being installed, so the 3 is the 3D engine. React 3/fiber lets us use it inside React, and React 3-dray is a helper library that includes pre-built components like orbit controls, stars, and more. Okay, all right, now let's start our application again by saying npm run dev. Okay, so let's just refresh the page. Great. All right, now we can start setting up our 3D scene. In React 3 Fiber, everything happens inside a canvas component, which represents the 3D world. So let's go ahead and create that. First of all, let's import canvas component from React 3 Fiber. So let's see, import canvas from React 3 Fiber. So think of canvas like a container for our entire 3D world. Okay, so now let's remove this h1, and here let's say that we want to have our canvas, and here we can say your 3D component goes here. So let's save this file, and we will not see anything yet, but that's okay because we will add objects next. So now we can make sure that everything is rendering correctly by adding a test object, a simple sphere. For that we can remove this comment, and we can say mesh, and let's close this tag. So mesh is a container for any 3D object, okay? And here inside this tag we can define a sphere geometry, so it will define the shape. Okay, so let's say sphere geometry, and we can accept it. So sphere geometry defines the shape, in this case a sphere with radius 1 and 32 segments. And then we can have merge standard material. It will define how the surface looks, and we can set its color to orange. So again, inside our canvas we can place any 3D object using the mesh component. A mesh in Three.js basically means a combination of geometry and material. And inside here we have sphere geometry. The word geometry always refers to the shape of an object, and here we have arguments property, means arguments, and we pass in three numbers here, 1, 32 and 32. So the first number 1 is the radius of the sphere, so how big it is, and the next two numbers represent the segments, basically how smooth the sphere looks. The more segments, the smoother the sphere, but the more performance it uses. So in our case 32 by 32 is a good balance. Okay, then we can have mesh standard material, and we can say that color will be orange. So the material defines how light interacts with the surface. So we are using mesh standard material, which reacts to light realistically, meaning if we add lights later we will see shadows, reflections and highlight. Okay, and now let's save this file. And now as you can see we have a circle, which is really great, guys. And in 3D graphics everything is black by default. Objects don't show up unless there is light in the scene, so we can add some light. We will use two types of lights. Okay, so above this mesh, let's say that we want to have ambient light, and when it comes to intensity we can say 0.3. So ambient light provides soft global lighting. It shines equally in all directions without creating shadows, and the intensity value controls how bright the light is, and its value can technically go higher than 1, but usually it's between 0 and 1. So 0.3 means 30% of full brightness. Okay, next we can add directional light. So let's say directional light, and we can say that a directional light is like sunlight. It shines from a particular direction but doesn't fade with distance, and the position defines where the light source is located in the 3D space. So it takes three values, x, y and z, and here we set everything to be 5, meaning the light comes from 5 units right, 5 units up and 5 units forward in 3D space. And the intensity of, let's say, of 1.5 means that this light is a bit stronger than the default, which is 1, making our orange sphere nicely bright and visible. So now let's save this file, and as you can see it is like the sun. Okay, so we have an orange sphere with some soft shading, darker on one side and brighter on the other side. So that's how we know lighting is working properly. So far everything looks great. We have set up our canvas, added an object and made it visible with light. So if you see this sphere, congratulations, your Three.js setup inside React is working perfectly. So in this first part we have successfully set up a new React project using Vite, cleaned it up, installed Three.js and React 3 Fiber, and rendered our first 3D object with lighting. In the next part we will start transforming this into our actual solar system. We will add the sun, multiple planets and start animating their orbits. Alright guys, now that we have our 3D scene working with a test sphere, it's time to build the actual solar system. First we will add the sun, Then we will add multiple planets that orbit around it. And we will also make it easy to add more planets later by creating a reusable planet component. So before we create the sun and planets, let's add textures, images that will make the sun and planets look realistic. So inside public folder, I will create a new folder called textures, and inside it I will add images named like sun, earth, Mars, and so on. So using textures makes our spheres look like real planets instead of plain colors. So as you can see, I added these images. You can find these images in the internet. I find it on this website. So it is called Solar System Scope, and you can download different kind of images that you need in different resolutions. And there are not only planets, but some other images as well. Okay. And I downloaded all my images in 2K resolution. All of them are in 2K resolution. Or you can get these images from my GitHub account. The link is in the video's description. So if we go to Earth, it will look like this. Mars will look like this. Neptune will look like this. Okay. So now we have our textures, and now let's create a sun component. So inside source folder, let's create a new folder called components, and inside let's create a sun component. Okay. So first of all, let's say that we want to load the texture image for the sun. So let's say const sun texture. Let's say sun texture will be equal to use loader. So use loader is to load external resources like images, and it works like a hook in React. So let's import use loader from React 3 fiber, and we also need to import texture loader. It is a built-in Three.js loader for image files. So let's also import it. Okay, so as you can see here, we have sun texture. It will load the sun image so we can wrap it on a sphere, and this path refers to this folder. Okay, now let's say that we want to return mesh component again, and we can accept it for now. So again, mesh is the combination of geometry plus material, and this will be the 3D sun. Now we have sphere geometry, and when it comes to radius, let's say that it will be 1.4, so it will be slightly bigger than our test sphere, and 32 by 32 are the width and height segments. This controls smoothness. More segments, smoother sphere. And when it comes to, actually here we need to have mesh. So let's say mesh basic material. And when it comes to map, it will be equal to sun texture. So mesh basic material displays the texture without reacting to light. And it can be perfect for the sun because the sun emits light itself and doesn't need shading. Okay. And here we just refer to our sun texture. So now let's save this file. And inside app.jsx, let's say that we want to use it. Let's remove this mesh and let's import our sun component. So let's save this file. And as you can see, it looks like a sun. So as you can see, I need to zoom to make it 100%. So let's say that it will be 100%. Okay. As you can see, now we have our sun. We can make it even closer like this. And this is how it looks, but I will make it to be 100. So this is a glowing sun in the middle of the scene, and notice that it looks bright even without strong lights. That's because we used mesh basic material. And now inside sun component, if I remove map, when I refer to sun texture, let's see what will happen. As you can see, it is gray, but let's return it. Okay. And as you can see, now we have our sun. So by doing map, we just refer to our sun texture. Okay, that is great, guys. Now we need to create a reusable component for planets, and each planet needs a texture, a radius, a distance from the sun, a speed, and rotation on its own axis. Okay, so let's create a new component here. Let's call it planet.jsx. Okay. So as I said, each planet will have its own name, radius, then distance, speed, then elapsed property. So elapsed is total time passed used for smooth orbit calculation. Elapsed means the total time that has passed since the animation started. You will understand it better as we keep going. And is post state. Okay, so isPost is a Boolean property to stop animation when post. Now we need to load the texture for the planet. Okay, so let's create a variable called texture. So let's say const texture will be equal to, again, as I have said, I have already mentioned about use loader. So let's import use loader and texture loader again. And when it comes to name, so here we will load the images from public textures folder, and we can ensure that the file name matches file names like Earth, Mars, and so on. Great. Now we can create a reference to the mesh. So let's say const mesh ref will be equal to use ref, and let's import it from React. So mesh ref will allow us to directly manipulate the planet's rotation and position. So now we can have an animation loop. For that we can use frame. So let's say use frame from React 3 fiber. So use frame will run on every frame automatically. And here we can have state and delta. So state contains info about the current frame and it will not be used here. And delta represents time in seconds since the last frame, and it will ensure smooth animation independent of frame rate. And now we need to do the following. If post is true, if is post true, we need to stop rotation and orbit. So we need to say if is post, we just need to return. Otherwise, we need to have self-rotation, like planet spinning on its own axis. So for that, we can use our mesh ref variable, and we can say dot current dot rotation dot y plus equals, and we can have delta, and we can multiply it by 0.8, for example. So rotation dot y is the rotation around the vertical axis, and when we say delta multiplied by 0.8, we just control speed. So smaller will be slower, bigger will be faster. Okay, and now we can implement functionality to be able to orbit around the sun. So let's say const angle will be equal to elapsed multiplied by speed. So angle in radians grows over time to move the planet around the sun. And now we can have x coordinate of circular orbit. So let's say that we can just accept it, because here we will have x coordinate of circular orbit and z coordinate of circular orbit. So using cos and sin creates a circular path in the xz plane. Okay, and it may be like a bit confusing for you guys, but if you try to deal with these parameters by yourself, I think that you will have a better understanding. Now let's say that we want to return our mesh component. So let's say that here we want to have our mesh, and when it comes to reference, let's refer to our mesh ref variable. Oops, let's have it here and let's put it here. Okay, so by doing this, we attach the reference so we can manipulate it. And then we can have position property. So let's see position, and we can say that it will be equal to distance. And here we can have 0 and 0. So what does it mean? So here we set initial x, y, and z coordinates. Okay, we just set initial coordinates, and then we can have our sphere geometry inside mesh component. Let's say that we want to have sphere geometry with these arguments. So we have our radius from our app.g6, we will have it from our app.g6. Here we have our radius, and again 32 and 32 are for width segment and height segment. It will control smoothness, and radius comes from props, as I have said, and segments are fixed at 32 for smoothness. And after this sphere geometry, we can have mesh standard material, and again we can refer to our texture. So mesh standard material reacts to light, and map texture applies the loaded texture to the sphere. Okay, so let's save this file. And now inside app.g6, we can render our planets inside the canvas. We can define an array of planets with all their properties. Then we can loop through them using map to generate multiple planet components dynamically. So this way, adding or removing planets is super easy, no repeated code. So first of all, here let's say that we want to have some states. So let's say that we want to have states called elapsed, set elapsed. And let's import use state from React. So elapsed keeps track of total time for animation, and we need to create a state for isPost. So let's say isPost, and by default it will be false. Now we can define planets, like let's say that we want to have planets definition. So let's say const planets will be equal to, and here we need to have our planets data. So as you can see, now each planet has its own name, radius, distance, and speed. Okay, and now let's cut this canvas, and let's say that here we want to have fragment, here we want to have canvas, and then above this canvas we want to have a button to be able to pause or resume animation. Okay, so here we can say isPost will be resume. So if isPost true, we will have resume. If not, we will have pause. And we can see that when we click this button, so let's see, when we click this button, we can say set isPost, and here we can get access by saying, for example, P, and we can say make it to the opposite. So if it was true, it will be false. If it was false, it will be true. So we will be able to switch between this resume and pause. And we can quickly apply some styles to these buttons. So let's say style, and let's just quickly apply some styles. Let's say that position will be absolute, and top will be 20, then right will be 20. Z index will be 100, so that it will be on top of everything. And we can give some padding. Let's say that from top and bottom it will be 12 pixels, and from left and right it will be 20 pixels. Let's say that font size, let's say that it will be 20 pixels, for example. And when it comes to background color, we can also control it. So let's say that if isPost true, we want to apply, for example, this color. But if isPost isn't true, we can apply this color. Oops, I need to have one more quote here. Okay, so let's say that in this case, we want to have this color. Great. Then when it comes to the just color of the text, let's say that it will be white, border will be none. Then let's say that border radius, let's say border radius will be 8 pixels. Then cursor will be pointer. Font weight, let's say that font weight will be bold. And I think that that's it. Okay, now we just do some like styling even without tailing CSS and not mentioning like Daisy UI. I think that for this project, we can just have this kind of styling. Okay, so now we have styles for our button, and now let's work with canvas. So when it comes to canvas, we can see that we want to have camera prop, and we can say that here we will have position, and we can say 0, 10, and 20, for example. So it will be for X, it will be for Y, and it will be for Z coordinates. Okay, and after this position, we can have FOV, and we can say that it will be 45, for example. FOV stands for field of view, and it will represent angle in degrees. So here we have our ambient light, then directional light, then here we have our sun, and after that we can map our planets, we can render our planets. So let's say planets.map, here we will have planet, then each planet should have key, and here let's be careful with these curly braces. Okay, let's just accept it, and this is how it looks. And we need to import planet. So each planet should have key, name, radius, distance, speed, elapsed, and isPost. Then for the background, we can add stars. So let's say that after these stars, after these planets, we can have stars. And let's see that radius will be 100. Depth will be 50, for example. So radius sets how far the stars are from the center, basically the size of the star sphere, and depth controls how thick that star layer is along the view. Bigger depth means stars spread out more in space. Then when it comes to count, we can define how many stars we want. Let's say that we want 5,000 stars. And when it comes to factor, we can say that, let's say factor, it will be equal to, or saturation will be equal to 0, and we can say that it will be fade. So factor is like size multiplier. Saturation 0 means white stars, okay? Factor controls the size of the stars. Bigger number, bigger stars. And saturation adjusts the color intensity. 0 means pure white stars. And fade represents like stars fade out with distance. Okay, and after the stars, actually here we need to have stars, okay? So after stars, we want to have our orbit controls. And actually we need to import stars. So let's say that we want to import stars and orbit controls. So let's say orbit controls. So as I have said, stars will add a star field background for realism, and orbit controls will allow rotate, zoom, and pan the camera. Okay, now let's say that we want to have orbit controls. Here, let's say orbit controls. So as I said, it will let us to rotate, zoom, and pan the camera. Now we can add some properties to it to enable or disable some options. Okay, so first of all, here let's say enable pan, and here we can just say that it will be true. So it will allow the user to move the camera left, right, up, and down. Then let's say that we want to enable rotation. So here let's also say true. So it will allow the user to rotate the camera around the target. Then let's say that we want to enable zooming. It will enable zooming, okay? Then let's say that pan speed will be 2.5. So it will control how fast the camera moves when panning. Higher number, faster movement, smaller, slower. Then we can have rotate speed. And we can say that it will be, for example, 1.0. It will control how fast the camera rotates around the target. Then we can specify zoom speed. Let's also say that it will be 1.0. Then we can say that we can define minimum distance. So minimum distance, it stands for minimum distance the camera can go towards the target, and it will prevent camera from getting too close and clipping through objects. And let's say that it will be 2, and max distance, let's say that it will be 1000. So maximum distance, the camera can go away from the target, prevents zooming out too far and leaving the scene. And let's say that auto rotate will be disabled if is paused true. Okay, so let's say is paused. So we want auto rotating to be disabled when is paused true. And then we can say that auto rotate speed will be, for example, 0.4. So it will be like speed of the automatic rotation. Higher means faster, smaller means slower. And then we can specify mouse, let's say mouse buttons. And here we can say left will be for 3 dot. Actually, here let's say that we need to have curly braces and again curly braces. And here we can have left, middle, and right. But actually here we need to say 3 dot mouse. Let's say mouse dot rotate. Here we need to have, when it comes to middle, we need to say 3 dot mouse and dolly. And when it comes to right, we need to say 3 dot mouse dot pan. So the left mouse button rotates the camera around the target. Middle mouse button or scroll wheel will be responsible for zooming in or zooming out. And right mouse button is responsible for panning. Okay, so now let's save this file, and looks like we have an error. Let's find out. We have 3 is not defined. Okay, so here let's say that we want to import 3 from 3. So by doing this, we import Three.js itself to access constants like mouse or orbit controls mapping. Okay, so let's save this file. And we have an error Mercury undefined. Okay, so actually the problem is that inside planet we need to make them to lowercase. So let's see, to lowercase, so that we will have a perfect matching. So let's save this file. And as you can see, now we have this pause button, and at the same time we can interact with these planets. Okay, so now I will zoom to it. Okay, using my mouse I can zoom to it. As you can see, we have some cropping. Okay, but anyway, I can have some basic interaction, and this is how Earth looks like. This is the sun and other planets. Okay, and inside index.css, if I come to body, let's say that, for example, background color will be, for example, black. This is how it looks. Okay, here we have our stars, and here we have our button to be able to pause. Okay, we will deal with styles very soon, and this is how it looks right now. As you can see, camera is moving by itself. Okay, right now I don't do anything, camera is moving by itself, but now if I left click, I can like move like this. Okay, now if I go with, for zooming with middle scroll or scroll wheel, I can have effect like this. Okay, and now if I right click like mouse button, I can pan the camera. This is great, and this is how it looks. We have our 4 planets. Okay, that is great, guys. In the next part, we need to take care of our styles and implement the functionality that should be implemented. Okay, guys, and now to be able to get rid of this cropping, I'll simply add these styles. Okay, and now let's save this file. And as you can see, now it looks really perfect. So let's see it on big screens. That is really great. Now let's say that I want to zoom in. Now I can move like this. And it looks really great, guys. Okay, now I will add the other planets. Okay, guys, now I have added info about other planets. Now let's save this file. And this is how it looks, guys. Okay. It looks really nice. And also Jupiter will have, Saturn will have its own ring. So far it looks really great. Now we need to implement functionality so that they will be able to rotate on their own axis. Okay, so let's try to do it. Okay, guys, to make our planets move, we need a way to track time. So every frame will increase a time value called elapsed. So it will control the orbit of the planets smoothly. So think of it like a stopwatch that keeps running while the solar system is active. So to be able to make our planets move, let's create a component called animation controller. So let's see, animation controller. Okay. So it should accept isPost. So let's say isPost state and set elapsed function from app.j6. So isPost will stop the animation when it is true, and set elapsed will update elapsed time in app.j6. Okay, so now we will need to use useFrame. So useFrame will let us run a function every frame, which is like animation loop. So let's say that here we want to have useFrame. So let's say useFrame, and here we want to have state and delta. And if isPost isn't true, we want to say set elapsed previous plus data, like elapsed previous and plus delta. So delta represents seconds since last frame and ensures smooth animation independent of frame rate. And here we say only update elapsed when not paused. Okay, here we just increment elapsed time. We just have previous value of elapsed and we say plus delta. So we ensure smooth continuous time. Okay, and now let's just close it. Okay, and we just need to say that we want to return null. So this component will not render anything visually. It just updates time. So let's save this file. and we need to update app.j6. So let's come right here and let's say that we want to have our animation controller component right here, and we need to pass to it isPost. So let's say isPost will be equal to isPost and set elapsed to be equal to set elapsed. So it will update elapsed time every frame. So without this, planets would stay in their starting positions, okay? But we need them to move. And when we pass elapsed to each planet calculates orbit based on total elapsed time, and it will ensure smooth continuous movement for all planets. So now let's save this file. And as you can see, they start moving according to their data. So this is how it looks from top, for example. As you can see, each planet has its own speed. Some move very fast, some move a little slower, okay? So that's it. And now if I click pause, as you can see, all of them are stopped. And I decided to make this functionality on purpose because when they move, like, we may not be able to look at them like thoroughly, get additional info, I mean. But when we have pause, we like control it, okay? We have full control over what's going on. And we can move like this, we can zoom, we can do it like this, okay? So now I will resume, and as you can see, they start moving from where they stopped, okay? That's it. So that is really great, guys. If I click pause, I can resume, okay? But actually, let's refresh the page. And as you can see, first of all, pose is gray, and we need to work with these styles also. But anyway, overall, it looks cool. And when it comes to stars in background, you can also adjust the count. I mean, the really like how many stars you want. Right now we have 5,000. Maybe you want 10,000 or only 1,000. Okay, that is great, guys. So when it comes to these tiles, let's see that here we forgot to write this sign, so that's why it was gray, but now it looks nice. If we stop, it stops, and yeah, everything looks fine now. So that's it. In the next part, we need to implement Saturn ring and clickable planets. So when we click a planet, we should see info panel, okay? Like when, for example, I click Earth, I should see some info about this planet. When I click this planet, I should see some info about that planet, okay? Okay, so Saturn is a special planet because it has a ring, and we will make a group containing the planet and its rings, okay? So groups will allow us to move multiple objects together as one. So inside components folder, let's create a new component called SaturnGroup.j6. And inside textures, as you can see, I already have Saturn ring, and this is how it looks. Okay, so let's work with Saturn group, and for now I will make it to be paused, okay, so that it will not move. So when it comes to this Saturn, it should accept onSelect function. So let's say that here we will have onSelect. So it is like a callback to show info panel, then elapsed property. So let's say elapsed and isPost. So as I have said, elapsed is for total time passed for orbit animation, and isPost to be able to stop rotation when true. Now let's say that we want to get Saturn texture. So let's see, const Saturn texture will be equal to use loader, okay, use loader. And here we want to have texture loader, and let's also import it. And here we can say it directly. We can say Saturn.jpg. Okay, so we have Saturn texture. Now we need to have its ring. So let's say Saturn ring texture, or we can just say ring texture. Okay, and it will be like this. Let's just make sure that it matches the name. Yes, it is Saturn_ring. Great. Now we have our textures. We need to create reference to the group so we can move the planet and rings together. So let's create a variable called group ref will be equal to, use ref. So let's import it from React. Okay. Now again, we need to have use frame. As I have said, we have used it previously. So it will have state and delta. And if we need to work with this curly brace and parentheses. So if is post true, let's say if is post true, we just need to return. So we just want to skip animation if post. But if it's not the case, we can say const angle will be equal to elapsed, and we can multiply it by 0.3, for example. So we can adjust speed as needed. So we can like calculate orbit angle around the sun. Then we can have X position for orbit. So let's say group. So let's say group reference dot current dot position dot X will be equal to, for example, we can say 16 multiplied by math.cos function. So we will have distance from the sun, and the same for Z position, okay, for orbit. So we need it for distance in these directions, okay? And then we need to have Saturn, which will self-rotate on its Y axis. So let's say group ref, and here we can say Saturn's own rotation, and we can say that we want to multiply it by 0.8, for example. So again, here we use frame to animate orbit and rotation, and it is called every frame. And delta ensures smooth movement even if frame rate changes. And group ref dot current position moves the whole group around the sun in a circular orbit using cos and sinus, like cosinus and sinus. So now let's say that we want to return the group tag, which is used to group multiple 3D objects together. Okay, so let's say that we want to return group, and we want to refer to it by saying group ref. And here let's say that we want to have our mesh component, and we need to say when we click it, we can get access to this event object, and we can see that we want to have event stop propagation. So we want to prevent clicks from affecting other objects. Okay, and here let's say on select, we just want to pass Saturn. So when we click Saturn, the info panel pops up with planet facts, and stop propagation prevents clicks from affecting other objects. Okay, and here again, let's say that we want to have sphere geometry, and we can just have these arguments, and then we can have like mesh standard material, and we can refer to our Saturn texture, and then we can work with Saturn's rings. And when it comes to rotation, as you can see, we have minus math.p divided by 2, 0, and 0. So when it comes to this rotation, we have that it will rotate around X, Y, and Z axis. Okay, here we have ring geometry and its own arguments. So inner radius will be 1.2, outer radius will be 2.0, and segments will be 64. Then we have mesh standard material. We refer to our ring, and then we have side. It means that it will be double-sided. Then we have transparency, which is true. It means that transparent allows hole in texture. Okay, and we can have some opacity, or we can just remove it because we don't need it, I believe. So let's save this file, and now inside app.g6, let's try to use it. Okay, so let's come here, and under planets, let's say that here we want to have Saturn group. Okay, so let's save this file, and looks like we have an error. We have failed to resolve does the file exist. So let's make sure that we imported it. Yes, here it is. So here we have, here we have import is, but we don't actually need it. Let's just remove it, and let's save this file again. Let's click resume, and actually we don't see the ring for some reason. We need to find it out. We don't see the ring because we need to pass some states to it. Okay, of course, here we need to say on select will be equal to set selected, but we don't even have state for that. So inside app.g6, we need to create a state for that, and at the same time we need to pass to it elapsed, which will be equal to elapsed, and is paused, which will be equal to isPost. Okay, so we need to create a state for selected planet. So here let's say const selected, set selected, and by default it will be null. It means that which planet is selected for info panel. So let's save this file. And as you can see, our Saturn has its ring. Now if I pause it, let's come closer to it. As you can see, this is how it looks. Okay, I just need to get used to this controlling, like zooming, panning, and so on. So this is how it looks. And I think that it looks like nice. Okay, yeah, I think that it looks nice, but maybe we can make this to look even like a circle, because now it may look like not a circle. We can make it look like a full circle, because if we look from this angle, as you can see that now it doesn't look rounded. Okay, yeah, it doesn't really look rounded. And let's see what will happen if we remove transparent to be true, for example. Let's just remove it and save this file. So now if I refresh the page, let's say that I want to pause. Yeah, and this is how it looks. Okay, I think that for now it looks nice. Oh yeah, now it looks like a full circle because I just didn't see it. Okay, this part is circle. It means that it is completely circle, guys, because this is how it looks. Okay, great. But if I add transparency again, let's see how it will look. But if I add transparency, this part like is invisible. Okay, for now I will leave it like this, and we will come to this issue a bit later. Now we need to implement functionality so that when we click a planet, we should see some panel where we will get some info about this planet, and then we will come back to this issue. Okay, so let's do functionality for that. Alright guys, next let's make an information panel so that whenever we click a planet, we can see its short description. So for that, let's create a component. First of all, let's close this folder. Now let's create a component called info panel. Okay, so here we want to receive two props. Let's say that it will be planet, so it will be for the name of the selected planet, and then on close function that will close the panel. Okay, so now we need to create an object which will store info about our planets. So let's say const info, and now I will just I think that I can accept it for the sake of this tutorial. Now we have for Mercury, Venus, Earth, but we don't have it for the rest. And now I'm gonna just go ahead, copy and paste some info. Well, I have this info for all the planets. I think that now it will be better. So now we have info for our planets. Now we can say that here to this div we can apply some styles. So let's just quickly do it. You can skip this part if you don't want, or you can follow along with me. So let's say that position will be absolute, and bottom will be, let's say that it will be 30, left will be 30. Then let's say that padding will be like this, color will be white, and let's say that border radius will be, for example, 10 pixels, max width will be 300 pixels. Yeah, I think that we can just accept it, and let's say that z index will be 200, for example. Yeah, I think that it is correct. And now let's say that here we want to have h2 tag. So let's say that we will have h2 tag, and here we just want to show the planet itself, like its name. So let's say planet, and we can quickly give some styles to it. So let's say that margin will be 0, 0, 12 pixels and 0. And I mean, let's say that here we will have 8 pixels, and let's say that color will be this color. Great. Then we need to have a place for our description. For that we can use a p tag. So let's say p tag, and I think that we can accept it. So here we will have description, and when it comes to margin, we can say that it will be like we can specify margin bottom, okay? And then we need to create a button to be able to close the model. So let's say that when we click it, we want to close it, but it should be right here. And we can quickly give some styles. Let's say that here we will have the following styles. Background color will be this color. So let's just take it. So let's say background will be this color. Then we can say that border will be none and color will be, for example, this color. We can give some padding, which will be 8 from top and bottom and 12 from left and right, and we can accept it. And here, let's say that for the text we want to have close. So let's save this file. And now let's go to app.jsx and finally use this component. Let's say that under this canvas, we want to have our info panel component. So let's say info panel, and we need to pass to it our planet. So let's say planet will be equal to selected, and we need to pass to it a function called onClose. So here let's say onClose set selected to be null. And at the same time, we should see this info panel when selected is true. So let's say if selected, then we want to render this component. So let's save this file. And now let's say that, for example, I want to click Earth. So let's click Earth. Well, look guys, right now it only works for Saturn and not for other planets because we don't pass on select function to our other planets. So that's why we can't see it. So let's quickly fix it. So let's go to app.jsx, and here when it comes to, let's just find it. When it comes to SaturnGroup, as you can see, we can pass it. We say on select, set selected. But when it comes to our planets, we don't pass it. So first of all, let's pass it to our planets. Now inside planet component, let's receive it. Okay. And now when we click this mesh, we need to use that function. So let's say on click, and here we need to use a callback function. So let's say on select, and here we need to pass our name, which we also get from these props. So let's save this file and try one more time. So now let's say that I want to click Earth, and as you can see, I see info for Earth. Okay. Now let's resume, and now I will try to click, for example, this, and as you can see, it is Jupiter. And we see some info about it, and it looks really nice. Okay, we can interact with it. We can click a planet to get additional info, and that is really great, guys. So now, as you remember, I said that we need to deal with this Saturn because, as you can see, its reading doesn't really look rounded. Okay, so let's try to deal with it. So now I will pause it. And now let's come closer to it. Okay, as you can see, it isn't really like fully rounded. So let's deal with it. Well guys, at first I tried to use a real Saturn ring image as the texture, but it looked cropped and didn't cover the whole ring as you saw. So it's not a bug in the code. The geometry is fine. The problem is that the image itself has transparency in some parts and wasn't designed to wrap perfectly around a 3D ring. So to make it properly, the image would need to be edited so the center is transparent and the ring part fills the correct area. And we can make sure, and for simplicity, we can remove our image and we can use this color instead. And as you can see now, it is perfectly like circle, okay? It proves our point and means that the problem is in the image. But anyway, I want to use the image. So let's have it, okay? And looks like it is gone, but I believe that if we refresh the page, it should be here. So here it is. Okay. So yeah, that was the problem, guys. Well, guys, as you can see here, I have Saturn, but at the same time, here I also have Saturn. So to fix it, I just need to remove this Saturn from here. And that's it. So let's save this file. Well guys, we have built our very own 3D solar system in React.js. Some parts were really confusing, like figuring out the right props, values, and a bit of tricky math, but we got through it, okay? And I hope that this inspires you to try 3D in React too. And I believe that it was a helpful video. So if you find this video helpful, please hit the like button and subscribe to this channel if you haven't done it yet. Thank you. I really appreciate it.